Okay, in this video we're going to take a look at some trigonometry in the unit circle and come up hopefully with a couple of techniques to help you remember some of the common angles that you might be responsible for in calculus. Let's start with a circle, and we will try and create a unit circle here, and hopefully that's not too much of an ellipse, but let's see. So right through the middle of that circle we have a circle, and it has a radius of 1 unit. So that's sort of where we get this term. So the length of this radius is equal to 1 no matter where it's located. From the center out to any edge of that circle is equal to 1. So its radius is equal to 1. So that means that at these intersections of the x and y axis, it's going to have coordinates 0 and 1 or 1 and 0 depending on where you are. So this one is 1 comma 0, and this one will be 0 1, and over here on this intersection it's going to be negative 1 for the x coordinate and a 0 for the y, and over here on this negative intersection of the y-axis it has an x component of 0 and a y component of negative 1. Alright, so these are all going to come in handy in a minute, and so let's take and just start by counting some of the key spots. So remember, we're mainly going to be dealing with radians, but we can talk about degrees as well. So when I start off at this very first spot, I'm at 0 radians, and whenever I get up to this y-intercept up here at 90, I'm at pi over 2. So we have pi over 2 right here, and that's a half a pi. So let's see if I can trace that. That would be this section right here, right? You can see that that's a 90-degree angle. Okay, and when I get over to this section, it's not what I wanted to do. When I'm right over here, I am at 180 degrees, or we just call that pi. So let's call that pi. And when I move over another 90 degrees, I'm at 3 pi over 2, or 1.5 pi. And whenever I make a full lap, I made it back to the origin, I'm at 2 pi. Okay, so that's generally how we count the unit circle. And we're going to further subdivide just the first quadrant to begin with, and we'll talk about how to calculate those angles. Okay, so what I'll do now is just sort of break out the first quadrant if I can. Just sort of erase all of this, and we can come back to that later if we need to. So there we are. We have our unit circle in the first quadrant. So we still have our x and our y, and it's still 0 1. So we'll see if we can draw a triangle, and we'll use a different color, let's say green. So if I take this unit circle, and if I drop it down from right here, you can see that it forms a right angle, and you sort of have the x component right here, and the height of this guy would be somewhere right here, right? So we form ourselves a right triangle. We have our x and our y height, right? And so you might recall from when you first learned about sine, cosine, and tangent that you probably learned something about SOHCAHTOA, right? So the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So first of all, it's worth noting that the angle that we're dealing with, let me draw the triangle over here, And let me represent the origin with the red dot right here, like so. The angle is usually expressed in terms of theta, and that would be given as right about here. So it's in here, we have our right angle, and this is our x component, and this is the height, y, and remember our radius is equal to 1 right here. So if we just use our SOHCAHTOA, we look at this and we see that sine is equal to opposite. The opposite of this is y over our hypotenuse, which is the radius, which is equal to 1. So on the unit circle, keep in mind it's only on the unit circle, the sine is just simply y, the y component, y divided by 1. So cosine is equal to the adjacent. Well, the adjacent would be the x component, right? Just adjacent to this theta. And tangent is opposite over adjacent. Well, remember the opposite was y over x. So that's basically how we think about this unit circle. So one thing we can say is sine is, it is true it's opposite over adjacent, but it's really all about the letter y. And cosine is all about the letter x. Alright, so hopefully that's a little bit of refresher for you. And now we'll move on and talk about the other three less common trig identities. So we have sine, cosine, tangent, and then we have cotangent, which by definition is just the inverse, or not the inverse, but the reciprocal of tangent. So let's see, we'll switch this, and that would be, we'll do this in green, would be x divided by y. And then the next identity we want to talk about is secant, and secant is simply 1 over x, or the reciprocal of cosine. And then finally, the last thing, the cosecant of theta would be 1 over y. So if we think about this in terms of a shortcut to help us remember this, if we line them up like this, in this fashion, sine, cosine, tangent, cotangent, secant, and cosecant, and we realize the relationship as a reciprocal, we can draw ourselves a little rainbow. So tangent is related to cotangent. Cosine is related to secant in the fact that they're reciprocals of each other. And then finally, sine has a reciprocal relationship with cosecant. So if we set this up, we'll notice a few patterns. We have every other identity starts with the letter C. You have a C here, you have a C for cotangent, and you have a C for cosecant. Alright, so with this in mind, we're going to develop a little trick to help us remember these certain values. So let's back it up a slide or two, and let's take a look at this hand trick that somebody has developed to kind of help us remember it. And you can see over here I've provided this the rainbow over here, so we have just another formal or informal definition of sine. It's all about the y, and cosine's all about the x. And if you'll kind of think about this for a second, if you imagine that this is the y-axis where your hand is, and this of course would be the x-axis. Somebody developed this pretty neat little trick, and basically your thumb is 90 degrees, or pi over 2, and your pointer finger here is pi over 3, the middle finger is pi over 4, and your ring finger is going to be pi over 6, and then your pinky, which if you could stretch it out on the x-axis, it would actually be sitting on the x-axis. So your thumb is on the y-axis, and your pinky is on the x-axis. So it turns out that all of these so-called reference angles, because these are in the first quadrant, these are all first quadrant that we're talking about, cosine is the square root of your upper fingers divided by 2. And sine is your lower fingers, square root of those divided by 2. And then to find tangent, you simply flip your hand upside down, and tangent is going to be the square root of the fingers that are above the bent finger divided by the square root of the lower fingers. Okay, so let's take a look at some examples here, or an example or two. And first thing we want to do is identify which finger this is. So since that's the pointer finger, we could figure out pi over 3. And let's do sine. And let's do cosine of pi over 3. And then we'll do tangent. And we'll talk about technique for these here. So since you have this finger bent over, it's not part of the count. And if you look at this little chart here, sine is the square root of your lower fingers. So how many fingers will be below your left hand? This is your left hand, by the way. I think I failed to mention that. So below your bent finger you have 1, 2, 3 fingers. So this is going to be simply the square root of 3 divided by 2. And you look at this, and sine is all about the letter y. So do you have any is this positive in this quadrant? And the answer is yes. Everything's positive in quadrant number 1. Okay, let's take a look at what would cosine be. Alright, well, you still have this pi over 3 finger bent, and the fingers that are above on your left hand would just be this 1, right? So it's going to be equal to the square root of 1 divided by 2, and of course the square root of 1 is 1, so simplify when you can. Alright, and now if you look at this little chart above here, it tells you to flip your hand over when you're calculating tangent. Flip your hand on tan. It kind of rhymes, I guess. So if you bend over this finger and flip your hand over, what would you have? Well, if you flipped it over, you would kind of have 3 fingers above, right? You'd have your middle finger, your ring finger, and your pinky finger above, and this is kind of your bent finger. I'll go ahead and shade that in. And then of course you would have your thumb below right here. So tangent would be the square root of 3 divided by the square root of 1, which of course reduces to just the square root of 3. Okay, so I encourage you to get a unit circle that's already completely filled out, or have your calculator out, and just kind of quiz yourself to see how you're getting this concept. So let's take a look at a blank unit circle, and maybe we'll discuss just a little bit about this. You've got yourself the 4 quadrants. You have quadrant number 1 up here, quadrant 2, quadrant number 3, and quadrant number 4 over here. And one thing I want to mention is, anytime you're working with this, until you get really, really familiar, it's always helpful to go ahead and put down the Trig Rainbow so that you can easily refer to this and have it all in one handy spot. But you'll notice here that we have 1 angle that we need to deal with, 2 angles, 3 angles, and you're thinking to yourself, but you have 5 fingers, right? Well, here's the 4th angle right here, the 90 degrees, or the pi over 2, and then the 5th finger is your thumb, which is 0. Okay, so let's take a look at moving around this unit circle, and let's talk about your reference angles. Okay, so the first angle that I'm going to draw here, try not to get too crazy with the colors, but this first angle is a very small angle. So when you're at 0, let's see if we can erase this one. When you're at 0, you don't have any height at all, right? And if you don't have any height, then the y value is equal to 0 and the x value is equal to 1. So the cosine of this, since cosine is all about the x, is equal to 1 when you're at 0. So it turns out that these coordinates, when you're at the axis, that tells you what cosine is, and this y value tells you what sine is. Alright, so let's go ahead and continue building this, at least in the first quadrant. And this angle, which we'll do in pink, is made up of pi over what? Pi over 6. Pi over 6. And you can see that pi over 6 is wider than it is tall, right? Look at the height of this. It's very short compared to the width of this, right? The width of this, if you drop a triangle down here, would be somewhere right in there. So it makes sense that the cosine, which is all about the x, is going to be a larger number than sine. Okay, so I'll let you practice that. But what I want to focus on now is, this is pi over 6, and pi over 6 we can use our hand trick. In fact, this would be your ring finger, right, on your left hand. But notice over here in quadrant 2 that we also have that same angle, but it's way over here, right? It's in reference to the x-axis. It's just as wide there, right? And what about in quadrant 3? In quadrant 3 we have this angle. So it's the x-axis here, and that small little line right there. And then finally in quadrant number 4 we also have an angle that is just as wide as that, and you can see that it's right here. So how do we count these angles? Okay, well, the key when you're dealing with radians is to think about the denominator. Okay, so if you're counting this, let's go ahead and let's label these other axes over here. So remember from the first slide we talked about, this was pi over 2. Pi divided by 2 is right at the 90-degree mark, and this is 3 pi over 2 down here at 270 degrees. And if you make one full rotation, you're going to get 2 pi's, 2 pi radian. So let's count and think about the width of this pink angle. It's pi over 6, right? Well, if you add another pi over 6, you would get 2 pi over 6. And I'll try to do that one with this green highlighter. Oops. You get 2 pi over 6. But what do you notice about 2 pi over 6? It's two of these pink angles together, and I drew it with the green. 2 pi over 6 reduces to what? Reduces to pi over 3, that's correct. Which means that it doesn't have a denominator of 6, so we're not going to use the reference angle that we've defined here. Okay, let's move on. And what's after 2 pi over 6? You have 3 pi over 6. So if you reduce 3 pi over 6, that reduces to what? Pi over 2, which is already defined at this 90-degree mark. So we're just going to keep counting. We're going to add 1 pi over 6 until we get to one of our angles. So 3 pi over 6, 4 pi over 6. 4 pi over 6 puts me right here. Puts me right here, which reduces to what? 2 pi over 3. And then finally, if you add 1 pi over 6 to 4 pi over 6, remember we had 4 pi over 6 right here, you add 1 pi over 6 to it and you get 5 pi over 6. So this value right here is 5, let me do it back in pink. This is 5 pi over 6. Okay. Well then if you add 1 pi over 6, you get 6 pi over 6. 6 over 6 reduces to pi, which is right here. And then finally this guy, if you add 1 pi to 6 pi, you get 7 pi over 6. And you can see that we're just going to keep counting by adding a pi over 6. 8 pi over 6 would take me right here, reduces. 9 pi over 6 would take me to 3 pi over 2. You can see the pattern, 10 pi over 6. And then finally the very last one is 11 pi over 6, which is this pink angle over here in quadrant number 4. Okay, so if you followed along with all that, hopefully you'll be able to count your reference or your angles, and it'll relate you back to the reference angles. And all the reference angles are going to lie in quadrant number 1. So let's see if I can clean some of this up, and we'll go a little bit quicker when it comes to the other reference angles in quadrant number 1. So we have pi over 6, and we'll try to do this one in, say, orange. So in between pi over 6 and 90 degrees, right in the middle is this line right here, which is also known as pi over 4. Alright? So you can see that that angle is actually 45 degrees, or pi over 4 radians. And if we count in pi over 4s, you start with 1 pi over 4, and you add a pi over 4 to it, you get 2 pi over 4, which in fact reduces to pi over 2, which would put me right about here, right? What comes after 2 pi? 3 pi. So 3 pi over 4 is this in the second quadrant, and after 3 pi over 4, let's write 3 pi over 4 right here, you have 4 over 4 pi, which reduces to pi. And then finally this guy right here would be 5 pi over 4. 6 pi over 4 would reduce to this. And then over here in quadrant 4 we have 7 pi over 4. Alright, so we have just basically one more angle left to build, and I started building that one in green when we were doing pi over 6, because pi over 3 and the pi over 6 are very related to each other, because they're 30 degrees apart from each other, because this is 30 degrees, the pink one's 30 degrees, and the green one's 60 degrees, so they're separated by 30 degrees. So let's see if I can build that without getting too crowded in there. See that angle 60 that I just drew, and it turns out that there's another 60 degree over here, and if this is pi over 3, the green one, what happens if you add 1 pi over 3? You get 2 pi over 3. So let's find some space here. 2 pi over 3. At 3 pi over 3, you get a pi, which is the pink line, I already got right here. And then finally, this last one is, or not the last one, but the one in third quadrant is what? 4 pi over 3. 4 pi over 3. And then if you add 1 pi over 3, you get pi over 3. If you add 1 pi over 3 to 4 pi over 3, you get 5 pi over 3. Okay. So hopefully this will help you be able to identify points on the unit circle and how it relates back to the quadrant number 1. So hopefully you'll be able to take a blank unit circle and get some practice doing that.